Before the story begins, make sure to subscribe. These forgotten, real-life moments of impossible courage deserve to be told, and your support keeps them alive. August 19, 1942. 22,000 feet above Dieppe, France. The Spitfire's Merlin engine screamed as Flight Lieutenant James MacLaren pulled into a climbing turn, his oxygen mask fogging with each ragged breath. Below him, the beaches of Dieppe burned. Above him, 3 Focke-Wulf 190s dove like hawks. He pushed the throttle forward. The engine responded, but not enough. The lead FW-190 closed the gap. 400 yards. 300. MacLaren's altimeter needle climbed past 23,000 feet, and then he felt it, that sickening loss of power every Spitfire pilot had learned to dread at altitude. The Merlin engine, Britain's engineering crown jewel, the power plant that had won the Battle of Britain, was choking on thin air. The FW-190 didn't choke. It accelerated. MacLaren slammed the stick left, diving away from the climb he couldn't win. His wingman's voice crackled through the radio, "Brake right! Brake!" The transmission ended in static. MacLaren looked back. His wingman's Spitfire tumbled earthward, trailing smoke, one wing sheared clean off. The FW-190s banked in formation, turning for another pass. MacLaren's hands shook on the stick. He was faster in a dogfight, more maneuverable at lower altitudes, but up here, in the thin cold air above 20,000 feet, the German fighters owned the sky. He dove. Full throttle. Racing for thicker air where his Merlin could breathe again. 6 more Spitfires went down that day over Dieppe. 12 the day before. 21 the week prior. Back at RAF Tangmere that evening, the debriefing room fell silent as MacLaren finished his report. The intelligence officer wrote nothing. The squadron commander stared at the wall. Everyone in that room knew what no one wanted to say aloud. The Spitfire, the legendary fighter that had turned back the Luftwaffe in 1940, was being outclassed. Something was wrong with the Merlin engine at high altitude. But no one knew what. By late summer of 1942, the air war over Europe had shifted from survival to offense. The RAF needed altitude superiority to escort bombers deep into occupied France and Germany. But at 20,000 feet and above, the Spitfire Mark V, equipped with a Merlin 45 engine, was being systematically destroyed by the new German fighters. The statistics were brutal. Between June and September 1942, RAF Fighter Command lost 194 Spitfires in combat. 73% of those losses occurred above 22,000 feet. German FW-190 and Bf-109G fighters consistently outperformed Spitfires at high altitude by margins of 15 to 20 miles per hour in speed and 500 to 800 feet per minute in climb rate. The problem wasn't courage. British pilots were among the best trained in the world. The problem wasn't the airframe. The Spitfire's elliptical wings and lightweight design were aerodynamic perfection. The problem was the engine. The Rolls-Royce Merlin, a 27-liter V12 liquid-cooled masterpiece, had been developed in the 1930s with a single-stage, single-speed supercharger. At sea level and low altitudes, it produced over 1,400 horsepower. But as aircraft climbed higher, atmospheric pressure dropped. Less air meant less oxygen. Less oxygen meant less combustion. Less combustion meant less power. The supercharger, a mechanically driven air compressor bolted to the engine, was supposed to fix this by forcing more air into the cylinders. But the Merlin supercharger had been designed for low-altitude operations during the Battle of Britain, when Luftwaffe bombers came in at 15,000 feet or below. Now, in 1942, combat altitudes had climbed to 25,000 feet and beyond. The Merlin's supercharger couldn't keep up. And worse, no one at Rolls-Royce seemed able to fix it fast enough. Engineers at the Derby headquarters tried modifications. They increased impeller diameter. They adjusted gear ratios. They tested different intake configurations. Nothing delivered the power boost needed without sacrificing reliability or low-altitude performance. Meanwhile, German engineers had solved the problem with 2-stage superchargers, essentially 2 compressors in series, each boosting pressure incrementally. Their engines maintained power at altitude. British pilots died because of it. By August 1942, Air Marshal Trafford Leigh-Mallory sent an urgent memo to the Air Ministry. If we cannot match enemy performance above 20,000 feet within 6 months, offensive operations over the continent will become unsustainable. We are sending our best pilots into battles they cannot win. The memo landed on the desk of Lord Beaverbrook, Minister of Aircraft Production. He forwarded it to Rolls-Royce with a handwritten note in the margin. Fix this. No. But Rolls-Royce was a company built on tradition, precision, and hierarchy. Solutions came from senior engineers with decades of experience. Solutions were tested, retested, validated through proper channels. Solutions took time. What they needed wasn't time. What they needed was a miracle. Or a rebel. Stanley George Hooker didn't look like a man who would change the course of a war. Born in 1907 in Sheerness, Kent, the son of a grocer, Hooker was thin, awkward, and unervingly brilliant. He'd earned a first-class degree in mathematics from Imperial College London, followed by a doctorate in applied mathematics from Oxford. By 1938, at age 31, he was a lecturer in aerodynamics, respected in academic circles but unknown in the world of practical engineering. He had never worked in industry. He had never designed an engine. He had never even held a wrench professionally. When Rolls-Royce hired him in 1938, it was almost by accident. The company needed someone to analyze airflow through superchargers using mathematical models, tedious theoretical work that senior engineers didn't have time for. Hooker took the job because war was coming and he wanted to contribute. His colleagues at the Derby plant treated him with polite condescension. He was the mathematician, the academic, the man who worked with chalk and paper while real engineers worked with metal and oil. Hooker didn't mind. He was used to being underestimated. He spent his first year at Rolls-Royce studying one thing, the centrifugal impeller inside the Merlin supercharger. It was a spinning disc with curved blades that accelerated incoming air outward, compressing it before it entered the engine. The design had been refined over years by some of the best mechanical engineers in Britain. But Hooker saw something they hadn't. He saw it in the equations. Late one evening in March 1940, Hooker sat alone in his office, surrounded by charts showing air pressure, velocity, and temperature at different points inside the supercharger. He'd been running calculations for weeks, testing a hypothesis that seemed impossible. What if the impeller blades were curved wrong? Not wrong by much. Just a few degrees of angle. But enough to create turbulence, invisible eddies and vortices that robbed the supercharger of efficiency at high rotational speeds. Hooker drew a new blade profile on graph paper. Sharper entry angle. Smoother transition curve. Less aggressive exit angle to reduce back pressure. He ran the numbers. The theoretical efficiency gain was 8 to 12%. He stared at the paper for a long time. Then he folded it, slipped it into his desk drawer, and went home. Because Hooker knew what 8 to 12% more efficiency meant. It meant more air. More air meant more power. More power meant Spitfires that could fight at altitude. But he also knew something else. Changing the impeller design meant challenging years of established engineering. It meant telling men with 30 years of experience that they'd missed something fundamental. It meant risking his career on a mathematical theory that might fail catastrophically when tested in the real world. So he waited. He waited through the Battle of Britain in 1940. He waited through the Blitz. He waited through 1941 as the Merlin's altitude problem became undeniable. And then, in August 1942, after the massacres over Dieppe, Hooker pulled the folded paper from his drawer and walked into the office of Ernest Hives, the managing director of Rolls-Royce. He placed the drawing on Hives' desk and said 6 words. "I think I can fix the Merlin." Hives looked at the drawing for exactly 4 seconds. Then he looked at Hooker. "You're a mathematician," Hives said. "Not a mechanical engineer." "Correct," Hooker replied. "This impeller design has been used successfully for 8 years." "Also correct. And you believe it's wrong." Hooker hesitated. Then, "I believe it's inefficient. At high boost pressures, the blade angle creates compressibility losses. The airflow separates from the blade surface, creating turbulence that—" In English, Hooker. "It chokes. Above 18,000 revolutions per minute, The impeller can't compress air fast enough without losing efficiency. If we change the blade curve by 7 degrees here, he pointed, and extend the leading edge radius by 3 millimeters, we can maintain laminar flow at higher speeds. Hives leaned back in his chair. Outside, the sound of Merlin engines being tested on the outdoor rigs rattled the windows. How much power gain? Hives asked. 10%. Maybe 12. Theoretical. Yes. Have you built a prototype? No. Have you tested it? I can't. I don't have authorization to modify production tooling. Hives picked up the drawing, studying it. Hooker could see the calculation happening behind the man's eyes. 10% more power at altitude meant Spitfires that could climb faster, fight longer, survive. It also meant retooling production lines, scrapping thousands of existing impellers, risking engine failures if the theory was wrong. The Air Ministry is demanding results in 6 months, Hives said quietly. We have 3 other teams working on supercharger improvements. All of them are senior engineers with decades of experience. I know. If your theory is wrong, we waste time we don't have. I know. Hives set the drawing down. If it's right, he said, you'll have just saved the RAF. He opened his desk drawer, pulled out a requisition form, and signed it. You have 4 weeks, Hives said. Build your impeller. Test it. If the numbers match your theory, we'll put it into production. Hooker took the form with hands that didn't shake. And Hooker, Hives added as the mathematician reached the door. If this fails, don't bother coming back to Derby. Understood. Understood. Hooker walked directly to the machine shop. He knew the numbers were right. He'd checked them 100 times. But numbers on paper and metal spinning at 20,000 revolutions per minute under combat conditions were 2 different things. If he was wrong, pilots died. If he was right, and the impeller failed catastrophically during testing, destroying a Merlin engine worth more than his annual salary, he'd be finished. But he also knew this. Every day he hesitated, Spitfires fell from the sky. He found the senior machinist, a man named Tom Graves who'd been at Rolls-Royce since 1925. I need an impeller machined, Hooker said, handing over his drawing. Graves studied it, frowning. This isn't standard spec. I know. Blade angles wrong. Curves wrong. If this fails... It won't. Graves looked at him. You sure about that, Professor? Hooker met his eyes. No. But I'm sure about the mathematics. Graves smiled grimly. Mathematics don't explode when they're wrong. Then let's make sure the impeller doesn't either. 3 weeks later, at 11:47 p.m. on September 14, 1942, Hooker stood in the engine test cell watching a Merlin engine fitted with his modified supercharger spin up to full power. The noise was apocalyptic. The entire concrete building shook. Gauges trembled on the walls. Hooker watched the boost pressure gauge climb. Standard impeller, 12 pounds per square inch at 18,000 revolutions per minute. His impeller, 13.2 psi. Then 13.5. Then 14. His hands gripped the edge of the observation window. The engine screamed louder. The dynamometer, measuring raw horsepower output, showed numbers that shouldn't be possible. 1,565 horsepower at 20,000-foot equivalent altitude. That was 11.8% more than the standard Merlin. Hooker felt his chest tighten. The engineer running the test looked back at him through the window, eyes wide. Hooker nodded. Keep going. The throttle went to maximum. The boost pressure hit 15 psi, beyond any safe operating limit ever tested on a production Merlin. The engine held. No vibration spikes. No bearing failures. No compressor stall. Just raw, surging, impossible power. At 12:03 a.m., they shut it down. In the sudden silence, the test engineer opened the door to the observation room. Dr. Hooker, he said quietly, I've been testing Merlins for 7 years. I've never seen numbers like that. Hooker nodded. His throat was too tight to speak. He'd been right. But proving it in a test cell and proving it in combat were different things. And there was one more problem. The Air Ministry's procurement regulations required a minimum of 6 months of reliability testing before any major engine modification could be approved for operational use. Hooker didn't have 6 months. He had 4 days before his deadline with hives expired. He realized the truth then, standing in that test cell at midnight. He was going to have to break the rules. If he followed proper procedure, his impeller would be validated sometime in March 1943, after hundreds more pilots had died in outdated Spitfires. But if he bypassed protocol, installed his impeller in an operational aircraft, and got a combat pilot to test it under real conditions, he'd be court-martialed. Or he'd save the war. Hooker walked out of the test building into the cold September night. He knew what he had to do. And he knew it would cost him everything if he was wrong. The rain started just after midnight. Hooker stood outside Hangar 6 at RAF Tangmere, collar turned up against the wind, watching a Spitfire Mark VB being wheeled inside for maintenance. He'd driven 3 hours from Derby with a wooden crate in his car's trunk containing a single impeller, the one from the test cell. No paperwork. No authorization. No approval from Hives or the Air Ministry. Just a mathematician with a theory and 4 hours until dawn. Inside the hangar, he found the man he'd been looking for, Flight Sergeant Peter Davison, Chief Mechanic for 611 Squadron. Davison was 52 years old, gray-haired, perpetually covered in engine oil, and legendarily stubborn about proper procedure. "Dr. Hooker," Davison said, not looking up from the carburetor he was disassembling. "Bit late for a social call." "I need a favor, Sergeant." "Don't do favors. Do maintenance." Hooker set the crate on the workbench. "I need you to install this impeller in a Spitfire's supercharger. Tonight." Davison looked at the crate, then at Hooker. "That's not standard issue." "No." "You have authorization papers?" "No." "Engineering approval?" "No." Davison wiped his hands on a rag. "Then why the hell would I install unauthorized parts in one of His Majesty's aircraft?" Hooker opened the crate, revealing the impeller. "Because this modification increases high-altitude power output by 12%. Because Spitfires are being shot down every day at altitude. Because you've been watching pilots die in aircraft you maintain, and you know the engine's the problem." Davison stared at the impeller for a long time. "If this fails during flight," he said quietly, "the pilot dies. And I hang for it. It won't fail. I've tested it." "Where? When?" "Derby test cell. 3 days ago. Ran it at 15 pounds boost for 40 minutes. No failures." 40 minutes isn't combat. Combat is thermal stress, vibration, rapid throttle changes, inverted flight, 6G turns. Davison picked up the impeller, examining it in the worklight. "You're asking me to bet a pilot's life on mathematics." "I'm asking you to trust me." "I don't know you, Doctor." "Then trust the numbers. Or trust this." Hooker pulled a folded paper from his jacket, the report from Dieppe. 6 Spitfires lost in 1 afternoon. That's what happens when we don't change things. Davison read the report. His jaw tightened. Finally, he set down the impeller. "Which aircraft?" "Whichever one's flying combat patrol tomorrow morning." "That'd be EN 821. Wing Commander MacLaren's personal aircraft." Hooker felt his stomach drop. James MacLaren, the pilot from Dieppe who'd survived 3 FW-190s. "Will he agree?" Hooker asked. Davison smiled grimly. "MacLaren doesn't ask what we do to his engine. He just asks if it'll get him home." At 2:17 a.m., they began the installation. Removing the supercharger casing required disassembling half the engine's accessory section. Each bolt had to be torqued to precise specifications. Each gasket had to seal perfectly. One mistake, one loose connection, one misaligned bearing, and the engine would disintegrate at 20,000 revolutions per minute. Hooker watched, holding tools, his hands shaking slightly. Davison worked in silence, methodical and precise. At 4:30 a.m., he slid the new impeller onto the supercharger driveshaft, checking clearances with a feeler gauge. 0.003 of an inch tolerance, Davison muttered. If you're off by more than that, it'll contact the housing and grenade the whole assembly. It's within spec, Hooker said. Your spec or Rolls-Royce's spec? Both. Davison grunted, tightening the retention nut. Then the casing went back on. Then the intake ducting. Then the cowling panels. At 5:52 a.m., Davison stepped back, wiping sweat from his forehead despite the cold. Done, he said. But I'm not starting it until daylight. I want to see what happens. They waited. At 6:15 a.m., as gray dawn light filtered through the hangar doors, Davison primed the engine and hit the starter. The Merlin coughed once, twice, then roared to life. Hooker closed his eyes, listening. The sound was different, sharper, more aggressive. The supercharger whine had a higher pitch. Davison ran through the checklist: oil pressure, coolant temperature, magneto check, boost pressure. Everything normal. He throttled up to 2,850 revolutions per minute. Full combat power. The engine's roar deepened. The entire aircraft shook against its wheel chocks. Boost pressure, 14.2 psi. Davison looked at Hooker through the cockpit canopy, eyes wide. He throttled back, shut down the engine. In the sudden quiet, he climbed out of the cockpit. That's not normal, Davison said. That's more power than I've ever seen in a Merlin. I know. If MacLaren pushes it hard, really hard, will it hold? Hooker met his eyes. Yes. Davison nodded slowly. Then God help us both if you're wrong. At 7:30 a.m., Wing Commander MacLaren walked into the hangar, flight suit on, parachute slung over his shoulder. He stopped when he saw Hooker and Davison standing beside his Spitfire. Something wrong with EN 821? MacLaren asked. No, sir, Davison said. But we made a modification. Supercharger impeller. Should give you better performance at altitude. MacLaren looked at the aircraft, then at Davison. Approved. Davison hesitated. Hooker spoke instead. No. But it works. MacLaren studied him. You're the mathematician. From Derby. Yes. And you're telling me you modified my aircraft without authorization because you think it'll perform better? Yes. A long silence. Then MacLaren smiled, not with humor, but with the cold understanding of a man who'd watched friends die. Let's find out, MacLaren said. 7:51 a.m. RAF Tangmere. September 15th, 1942. MacLaren strapped into EN 821, ran through pre-flight checks, and taxied to the runway. Hooker watched from beside the hangar, stomach knotted with tension. The Spitfire's Merlin engine howled. The aircraft accelerated down the runway, lifted smoothly into gray morning sky, and climbed east toward the channel. Hooker checked his watch. 7:58 a.m. Combat patrol altitude, 25,000 feet. If German fighters appeared, MacLaren would find out if Hooker's mathematics translated to survival. Davison stood beside him, smoking a cigarette. Nothing we can do now but wait. I know. If it fails. It won't. But if it does, MacLaren dies, and we hang. You understand that? Hooker didn't answer. At 8:47 a.m., the air raid siren wailed. German bombers detected over Boulogne, heading for Dover. Fighter escort, FW-190s. Hooker's chest tightened. This was it. At 25,000 feet over the English Channel, MacLaren saw them, 12 Dornier bombers in formation, surrounded by 6 Focke-Wulf 190s. His wingman's voice crackled, bandits, 10 o'clock high. 26,000 feet. Higher than the Spitfires. Altitude advantage. MacLaren pushed the throttle forward. The Merlin responded instantly, not with the usual sluggish climb at altitude, but with a surge of power that pressed him back into his seat. The altimeter needle climbed 26,000 feet. 27,000. 28,000. He was overtaking the FW-190s. Impossible. The German fighters saw him coming and broke formation, diving to intercept. The lead FW-190 turned hard, trying to cut him off. MacLaren pulled into a climbing turn, a maneuver that should have bled off speed at this altitude, leaving him vulnerable. But the Merlin didn't falter. The supercharger whine was higher-pitched, almost screaming, but the power kept coming. He climbed through 29,000 feet. The FW-190 couldn't follow. MacLaren rolled inverted, pulled through, and dove back down with the sun behind him. The FW-190 pilot never saw him coming. One burst from his Hispano cannons. 2 seconds of fire. The FW-190's engine exploded in black smoke. The aircraft rolled hard right, spiraling earthward. MacLaren's wingman's voice, "Christ! Mac, how are you doing that?" MacLaren didn't answer. He was already climbing again, targeting another FW-190 that had broken away from the bomber formation. The German pilot was good, veteran, experienced. He reversed into MacLaren's turn, trying to force an overshoot. MacLaren throttled back slightly, matched the turn, then throttled forward again. The Merlin screamed. The boost pressure gauge hit 15 psi, deeper into the red than MacLaren had ever pushed it. But the engine held. He closed to 200 yards. 150. 100. Another burst. The FW-190's cockpit shattered. By 9:03 a.m., the German formation had broken off, retreating back toward France. 2 FW-190s shot down. No bombers reached Dover. No British losses. MacLaren descended back to 15,000 feet, hands still shaking on the stick, adrenaline burning through his veins. His engine gauges were all normal. No overheating. No vibration. No failures. He keyed the radio. "Tangmere Tower, this is Redcap Leader. Returning to base." At 9:17 a.m., EN-821 touched down. MacLaren taxied to the hangar, shut down the engine, and climbed out. Hooker and Davison were waiting. MacLaren pulled off his helmet, face streaked with sweat, and walked straight to Hooker. "For a moment," he said nothing. Then, "What did you do to my aircraft?" "Modified the supercharger impeller," Hooker said quietly. "Increased compression efficiency. I just outclimbed 2 FW-190s at 28,000 feet. That's not possible." "Apparently it is." MacLaren stared at him. Then he turned to Davison. "I want that modification in every Spitfire in the squadron. Today." "Sir, we don't have authorization." "I don't care. Get authorization. Or don't. But if that engine can do what I just felt it do, every pilot in Fighter Command needs one." He looked back at Hooker. "You just saved my life, Doctor. Probably saved a dozen lives today. How long have you been sitting on this?" 2 years, Hooker admitted. MacLaren's expression hardened. 2 years. While pilots died. "I didn't have proof it would work until—" "You have proof now." MacLaren turned and walked toward the operations room. Over his shoulder, "I'm calling the Air Ministry. Personally." Hooker stood in the morning sun, watching him go. Davison lit another cigarette. "Well," he said quietly, "you're either about to be a hero or a prisoner." Hooker nodded. He realized then that it didn't matter which. The engine worked. The modification worked. And that was all that mattered. September 18, 1942. Air Ministry, Whitehall, London. The conference room was silent except for the ticking of a wall clock. Seated around the table, Air Marshal Lee Mallory, Lord Beaverbrook, Ernest Hives from Rolls-Royce, 3 senior RAF engineering officers, and Stanley Hooker. On the table, MacLaren's combat report from September 15th, engine performance data from EN-821's post-flight analysis, and Hooker's original impeller design drawings. Lee Mallory spoke first. Wing Commander MacLaren's report claims his aircraft achieved sustained combat power at 29,000 feet and outclimbed German FW-190s at altitude. Is this accurate, Dr. Hooker? Yes, sir. And this performance gain resulted from an unauthorized modification you installed without Air Ministry approval? Yes, sir. One of the engineering officers leaned forward. Do you understand that bypassing procurement protocol is a court-martial offense? That installing untested components in operational aircraft endangers pilots? I understand. Then why did you do it? Hooker looked at him. Because following protocol would have taken 6 months. And pilots don't have 6 months. The room fell silent. Beaverbrook spoke next, his voice quiet. How many impellers can Rolls-Royce produce per week? Hives answered, if we retool immediately, 300. How many Merlins are currently in service? Approximately 4,000. But we'd prioritize fighters, Spitfires, Hurricanes, Mosquitoes. That's roughly 2,000 engines. Time to retrofit the fleet. 8 weeks. Maybe 10. Lee Mallory looked at Hooker. Doctor, what's your confidence level that this modification will perform reliably under combat conditions? 95%, Hooker said. We've tested it in the test cell, and Wing Commander MacLaren subjected it to combat stress far beyond normal parameters. It held. 95 isn't 100. Nothing in engineering is 100%, sir. But this is as close as we're going to get. Another silence. Then Beaverbrook stood. Gentlemen, I've read the casualty reports. I've read the intelligence assessments. We're losing this air war at altitude, and we don't have time to be cautious. He looked at Hives. Rolls-Royce will begin immediate production of Dr. Hooker's impeller design. Full retrofit of fighter command within 10 weeks. One of the officers started to object. Minister, without proper testing protocols. Testing protocols are written in peacetime. Beaverbrook cut him off. We're at war. Dr. Hooker gave us a solution. We're using it. He turned to Hooker. As for your unauthorized actions, the Air Ministry has decided not to pursue court-martial proceedings. Instead, you're being assigned to Rolls-Royce's Advanced Development Team, reporting directly to Mr. Hives. Your new role, supercharger development for all future Merlin variants. Hooker blinked. Sir, You broke the rules, Doctor. But you also saved lives. Don't make me regret this decision. No, sir. The meeting ended. As Hooker walked out of Whitehall into afternoon sunlight, Hives fell into step beside him. That was closer than you think, Hives said quietly. Half the room wanted you court-martialed. The other half wanted you promoted. What did you want? Hives smiled slightly. I wanted you to be right. And you were. By October 1942, Rolls-Royce had produced 1,200 modified impellers. By December, over 1,800 Spitfires and Hurricanes had been retrofitted. The results were immediate. RAF combat losses above 20,000 feet dropped by 34% in October alone. Spitfire squadrons began achieving parity with FW-190s at high altitude. By March 1943, RAF Fighter Command held altitude superiority over occupied Europe for the first time since mid-1942. The modification became standard on all new Merlin production. Hooker's impeller design was classified top secret and designated Modification 47C. His name didn't appear in any official documents. At a private ceremony at RAF Tangmere in November 1942, Wing Commander MacLaren presented Hooker with a silver cigarette case engraved with the words, "To the man who gave us altitude, the pilots of 611 Squadron." Hooker kept it in his desk for the rest of his life. But in the halls of Rolls-Royce, among engineers who'd spent decades perfecting the Merlin, resentment lingered. Hooker had bypassed seniority, ignored hierarchy, and proven their designs weren't perfect. Some never forgave him. One senior engineer was overheard saying, "Hooker got lucky. Mathematics isn't engineering." Hooker never responded to comments like that. He just kept working. April 1984. Derby, England. Sir Stanley Hooker, knighted in 1974 for his contributions to aviation, died at age 76. His obituaries mentioned his work on jet engines, his leadership at Rolls-Royce and Bristol Siddeley, his role in developing the Pegasus engine for the Harrier jump jet. Few mentioned the impeller. Fewer still mentioned that in September 1942, a mathematician with no formal engineering training had risked his career, bypassed military regulations, and installed an unauthorized modification in a combat aircraft, and in doing so, had changed the course of the air war over Europe. The modification that Hooker designed in 1940 and secretly installed in 1942 became the foundation for every subsequent Merlin variant. The Merlin 60 series, which powered Spitfire Mark IXs, Lancasters, and Mosquitoes, used evolved versions of his impeller design. By 1945, over 150,000 Merlin engines had been built using principles Hooker had proven in a single midnight test. The strategic impact is impossible to quantify precisely, but historians estimate that Hooker's supercharger work contributed to saving hundreds, possibly thousands, of Allied pilots' lives between 1942 and 1945. James MacLaren survived the war. He flew 247 combat missions, was credited with 11 confirmed kills, and retired from the RAF as a group captain in 1963. He never forgot the morning his Spitfire suddenly climbed like it had wings made of light. Peter Davison, the mechanic who installed the impeller that night, received no official recognition. He retired from the RAF in 1946 and worked as a civilian aircraft mechanic until 1971. He never spoke publicly about what he and Hooker had done. Hooker went on to design the Olympus engine that powered the Concorde. He revolutionized turbofan technology. He became one of the most respected aerospace engineers in British history. But the impeller, that first act of mathematical rebellion, remained his most important contribution, because it taught a lesson that transcends aviation, engineering, or war. Sometimes courage isn't about firing shots or charging hills. Sometimes courage is about trusting a calculation. Sometimes it's about knowing you're right and refusing to wait for permission when people are dying. Sometimes courage is a mathematician with a folded piece of paper, standing in a hangar at midnight, whispering to a mechanic, "I think I can fix this." Stanley Hooker didn't wait for the world to validate his genius. He didn't wait for committees to approve his idea. He didn't wait for senior engineers to acknowledge he might be right. He simply did the work. He solved the problem. And in doing so, he proved that the most dangerous thing in any system, military, corporate, scientific, isn't the enemy outside. It's the refusal to listen to someone who sees what others missed. The greatest innovations don't come from the top of the hierarchy. They come from the quiet rooms where someone decided the mathematics mattered more than the rules. And every Spitfire that climbed into the sky after September 1942 carried that truth in its engine, invisible, unacknowledged, but undeniable. One curved blade. One midnight installation. One forbidden choice. That's how wars are won.